So, as I mentioned before, there's a couple of skills here that we can do with these conjugates, right? One of them we illustrated previously, and I showed a couple examples in a video where we can actually take these ions and look at, we put them into water, right? Again, as part of some ionic compound. Do they form an acidic solution, a basic solution? We can calculate the pH, right? Using that equilibrium expression based on that ion, either that negative ion acting as a weak base, or the positive ion acting as a weak acid, and we can do equilibrium calculations and so forth to find the pH of those ions, or find out the pH of those solutions with those ions in them. Now, another sort of skill, if you will, we can do is, if we don't want to necessarily classify or find the pH of a solution like that, we can simply take any salt, any ionic compound, and decide whether it's going to produce a neutral solution, an acidic solution, or a basic solution, right? Just as simple as that, based on the ions that make it up, and following sort of the simple rules that we laid out before, whereas, what is the acid or base that it comes from? Is that acid or base strong or weak? And so let's kind of line that out. So if the cation, so we're talking about the positive ion, is the conjugate of a strong base and the anion is the conjugate base of a strong acid, then the salt or the ionic compound will form a neutral solution. So some examples might be something like sodium chloride, right, where the sodium ion here is the conjugate of sodium hydroxide, right, a strong base. The chloride ion is the conjugate of HCl, right, strong acid, right? Conjugates of strong acids or strong bases don't have any effect, right? So if they're both coming from a strong acid and base, then it's not going to have any effect. Neither of these are going to affect the pH. And we have a neutral solution. So that can be one type of ionic compound. Gives you no effect on the pH. Now, what if only the negative ion has an effect? So what if the cation, let's go back and do it in red. What if the cation is still the conjugate ion of a strong base like sodium, or calcium, right? Potassium, right? Any of these group 1 or 2 metals. But the anion is the conjugate now of a weak acid. Well, remember, the anions, or the conjugate bases of weak acids, can function as weak bases. So if you have this type of setup, you're going to generate a basic solution. So for example, let's look at this one. So I have potassium ion, right? It comes from, it would be the KOH, right? Strong base, no effect. But NO3, whoops, sorry, not NO3. NO2 is NO2 minus, the conjugate of HNO2, right? This is a weak acid, and so that means this is going to be a weak base. And so we have one with no effect, one that's weakly basic, we end up with a basic solution. So if only the negative ion affects the pH, then we're going to get a basic solution. The opposite, of course, would be true if only the cation affected the pH. So if the cation is the conjugate of a weak base, and the anion is the conjugate of a strong acid, then that means only the cation will affect the pH. And since the cation is the conjugate acid of a weak base, we're going to get an acidic solution. So here we have ammonium. Right? It's the conjugate of the weak base ammonia. So this is going to give you, an acidic, right? There's going to be a weak acid because this is a weak base, whereas the chloride ion is the conjugate of a strong acid, and so this is not going to have any effect on the pH, so we end up with an acidic solution. So if only the positive ion has an effect on the pH, then we're going to get an acidic solution. Now, those are sort of the more straightforward examples. There's 3 out of the 4. Now, the one example where before I get to that, there's one other one. Let's look at what if one of these is one of those highly charged cations. So if the positive ion is a highly charged metal ion, and the negative ion is the conjugate of remember this is a strong acid, so this is another place where knowing those strong acids is important, nitric acid, so no effect. So this is how these examples of salts that contain these high charged metal ions produce acidic solutions. Right? Now, the one that requires a little bit more thought is, what if they both affect the pH? What if the cation is the conjugate acid of a weak base, which would make an acidic solution, but also the negative ion is the conjugate base of a weak acid, which would make a basic solution? So is it going to be acidic or basic? Well, the pH depends on how strong they are, the relative strengths of this. So we have to compare the K values, right? So if I have ammonium fluoride, right? So one way to look at this, right, is to compare the two acids. So the acid here, right, the weak acid is ammonium ion, is one of the weak acids, and the conjugate acid of our negative ion, right, is HF. Right? If we look at the Ka values, right, the Ka for HF is bigger than the Ka of NH4 plus, than the Kb of the Kb, Ka of HF is larger than the Ka of NH4, and so it's going to win out, and the solution will be acidic. So we're essentially comparing these two. Let's Okay, let's go back and explain that last one again with some numbers. I think it'll make a little more sense here because I think I had some of my drawings off here a little bit. I was getting backwards of what I had written here. So let's just line it out here again. So when we're comparing a salt where we have both the positive ion and the negative ion are conjugates of weak acids and bases, we have to compare the effects. So if we take the Ka of our positive ion, right, which is going to be the one functioning as the acid, right? So ammonium here is our weak acid. The Ka of ammonium, right, is 5.68 times 10 to the minus 10. We take our weak base, the F minus, right, which is the conjugate base of our weak acid, HF. The Kb of F minus is 1.5 times 10 to the minus 11. So we can see here that the Ka, right, this right here is a bigger number than the Kb. So the acid wins out, meaning since this is a bigger number, it's going to be more product favored. So the equilibrium of ammonium producing hydronium ions is going to be more product favored than F minus equilibrium to produce hydroxide ions. And so more hydronium than hydroxide, Ka bigger than Kb, the solution would be overall acidic. And so that's how we can analyze one of these problems where both the positive ion and the negative ion have an effect.